System blockage refers to a situation where a process or flow within a system is impeded or halted. Understanding the potential causes and effective resolution strategies is crucial for maintaining optimal system performance. Blockages can manifest in various forms across diverse systems, ranging from mechanical to electrical to computational. In mechanical systems, a blockage might involve a physical obstruction, such as debris clogging a pipe or a jammed component within a machine. Electrical systems can experience blockages due to short circuits, open circuits, or overloaded components. Computational systems can encounter blockages in the form of software errors, resource conflicts, or data bottlenecks. Identifying the root cause of a blockage is the first step toward resolution. This often involves a systematic approach of inspection, testing, and analysis. Visual inspection can help identify obvious physical obstructions or damaged components. Testing can be used to isolate the affected area and pinpoint the source of the blockage. Analysis of system logs and performance data can provide valuable clues about the nature and cause of the problem. Once the cause is identified, appropriate corrective actions can be taken. These actions may involve removing the obstruction, repairing or replacing damaged components, reconfiguring system settings, or updating software. In some cases, a more comprehensive approach may be required, such as redesigning the system to prevent future blockages. Effective troubleshooting techniques are essential for resolving system blockages quickly and efficiently. One common technique is to divide and conquer, which involves breaking down the system into smaller components and testing each component individually. Another useful technique is to use a process of elimination, which involves systematically ruling out potential causes until the actual cause is identified. Documentation is also important for effective troubleshooting. Keeping detailed records of system configurations, maintenance activities, and past incidents can help identify patterns and prevent future blockages. Regular maintenance is a proactive approach to preventing system blockages. This includes tasks such as cleaning and inspecting components, lubricating moving parts, and updating software. By performing these tasks regularly, you can reduce the likelihood of blockages and ensure that your system operates smoothly and reliably. The specific steps involved in resolving a system blockage will vary depending on the type of system and the nature of the problem. However, some general principles apply across all systems. Firstly, always prioritize safety. Before working on any system, ensure that it is properly de-energized and that all safety precautions are taken. Secondly, use appropriate tools and equipment. Using the correct tools for the job will help prevent damage to the system and ensure that the work is done safely and effectively. Thirdly, follow a systematic approach. Avoid making random changes to the system without understanding the potential consequences. Fourthly, document your work. Keeping a record of the steps you took and the results you achieved will help you troubleshoot future problems. Fifthly, seek help when needed. If you are unsure about how to resolve a system blockage, consult with a qualified technician or engineer. The concept of a system blockage extends beyond physical or mechanical systems. It can also apply to abstract systems, such as organizational structures, communication networks, or even personal habits. In these cases, a blockage may manifest as a bottleneck in workflow, a breakdown in communication, or a self-sabotaging behavior. Resolving these types of blockages often requires a different set of tools and techniques, such as process improvement, conflict resolution, or cognitive behavioral therapy. However, the underlying principles remain the same: identify the cause, take corrective action, and prevent future occurrences. System blockages can have significant consequences, ranging from minor inconveniences to major disruptions. The cost of a blockage can include lost productivity, damaged equipment, and even safety hazards. Therefore, it is essential to take proactive steps to prevent blockages and to have a plan in place for resolving them quickly and effectively. In conclusion, understanding and resolving system blockages is a critical skill for anyone who works with complex systems. By following a systematic approach, using appropriate tools and techniques, and prioritizing safety, you can minimize the impact of blockages and ensure that your system operates at its full potential.